In today's video, we will be differentiating 4 different functions and we will be applying 2 or 3 different rules. We'll be applying chain rule, quotient rule, and product rule. So we must know that depending on the question given, what are some of the approaches, we must know the type of function it is or the kind of function it is and how to tackle it. So for the first one, we have the function 3x plus 1 all to power 3. So how do we solve it? Let's write down the function. To be able to do this, first we are supposed to differentiate with respect to x. So we have to name the function y. And looking at this very carefully, I can apply chain rule to solve this. So I will use chain rule as the easiest method to solve this. So to apply chain rule, I will consider 3x plus 1, whatever is inside the bracket, and name it any variable of my choice. So I will use u. So I'll say that let u be equal to 3x plus 1. So if u equals 3x plus 1, then the main equation will be y giving me u raised to the power 3. So you can also go over the video I have done under chain rule. You can search for chain rule for differential equations. It's on this page and you can go over it. So for this one, let's differentiate. We have u 3x plus 1. So we differentiate u with respect to x and we get du dx will be equal to, when we differentiate a constant, we get 0. When we differentiate 3x, we get 3 because there's a power here, 1 times 3, then the power, you reduce the power by 1. So 1 minus 1 will give you what? 3. Then we differentiate y with respect to u. So we have dy du will give me 3u all squared. So you multiply the 3 by the variable u, you reduce the power by 1. So when I reduce 3 by 1, I'll get 2. You can go over my video for general differentiation. The basic rules are there. You watch that video to get yourself prepared before you tackle this question. So in our next step, we can apply the chain rule by saying from chain rule, we have dy dx will be equal to the first derivative. What was the first derivative? Du with respect to x. So you write your du dx, then you multiply by the second derivative, dy with respect to u, dy du. So dy dx, what is du dx? We got 3, and the 3 is multiplying dy du, which is what? 3u squared. So now dy dx will give us 339u squared. But in the beginning, you said that let u be equal to 3x plus 1. So you can resubstitute this by saying that dy dx will be equal to 9 into 3x plus 1 all squared. So in the next example, we have sine 4x minus 1. So what you need to do is that we can also apply chain rule here to solve this. So I'll name everything inside the bracket with the variable u. So I'll say that let u be equal to 4x minus 1. So the main function will become y equals sine u. So now all you need to do, differentiate u with respect to differentiate y with respect to sine u. Du dx being equal to the differential of a constant is 0. And the differential of this will give us 4. Because 1 times 4, 1 minus 1. Anything to power 0 here will give us 1. And then dy du will give us, sine of u will give us cos u. From here, we apply chain rule by saying from chain rule, we are differentiating y with respect to x. So dy dx will be equal to the first derivative du dx times the second derivative dy du. So this one becomes dy dx will give us, what was du dx? It was 4. So we have 4 multiplying dy du was what? Cos u. So now we can rewrite this as dy dx giving us 4 cos u. But in the beginning, you said let u be equal to what? 4x minus 1. So you substitute it back by saying dy dx will give us 4 cos 4x minus 1. And this is your final answer. Actually, I went through these steps because this is a function given to you to differentiate. You can just do this straightforward in just one line. Let me put it that way. You can differentiate this straightforward. But because this is a question that has been given for you to differentiate, you need to use the chain rule to pass through steps to produce the final answer as I have here, so that you may not lose marks. But the other way is very simple. If you look at the function, it was a very simple function, and so all you needed to do was to say that dy dx will be equal to, you differentiate everything inside the bracket. What do you get? You differentiate 1, you get 0. You differentiate 4x, you get 4. So you bring the 4 outside. Then when you differentiate sine of everything, you get cos the same thing, cos 4x minus 1. And the answer will give you 4 cos 4x minus 1. And so this is it. When you use this one, if you are solving a question like this in exams, you may lose marks, because this is just a straightforward differentiation. It's very important to apply the chain rule to produce the final answer as we have here. But if you are solving any question and you come across something like this, you don't need to use chain rule, you just move straight forward. For this one, it's a product because we have x squared term multiplying another term. So we say that x squared is a function on its own, and sine 3x is also a function on its own. So two different functions, say f of x and g of x, multiplying each other. So we can apply product rule. Or you can say that x squared is a variable u, sine 3x is another variable, say v. So you can use them to solve. So this one we are applying what we call the product rule. So to apply the product rule, there are two ways. I will use the variable term. Let me use the first step, and then I'll use another term to differentiate. Let u be equal to the first function, which is x squared, and let v be equal to the next function, which is sine 3x. The function is in terms of y equals uv, called the product. So now you differentiate u with respect to x, differentiate v with respect to x. So I'll say that du dx will give us this times this, giving us 2x. 2 times x, 2 minus 1. That is it. Then we differentiate v with respect to x. dv dx will give us, for this one, because it's a separate function, a function we created, we can go straight by saying you differentiate this, you get 3. So you bring the 3 outside, then you differentiate sine 3x, you get what? Cos 3x. So you get 3 cos 3x. Then you can now apply the product rule. You write the formula by saying we are differentiating y with respect to x. So we say dy dx will be equal to v, the second function. You can also use the first function since multiplication is commutative. So v du dx plus u dv dx. So that is the formula. You write v, you take the derivative of u, you write u, you take the derivative of v. So you substitute the values inside. We have dy dx being equal to, what was v? We said that let v be equal to sine 3x. So we have sine 3x multiplying the derivative of u was 2x. So we have 2x plus, what was u? U was x squared. So I'll put my x squared here, multiplying what was dv dx. It was 3 cos what? 3x. So 3 cos 3x. Then we can now expand this by getting this will give us dy dx being equal to 2x sine 3x plus 3x squared cos 3x. So this time this, we can rewrite this term by saying dy dx will give us, let me write the x squared term first. So 3x squared cos 3x plus 2x sine 3x. So let's check. We have x here, so x is common. We can factorize x out. So dy dx be equal to x outside, 3x cos 3x plus 2 sine 3x. So that this time this will give us this time this will give us this. And this will be our final answer. There's another way you can solve this by applying the product rule without using the variable u and v. So let's try that one. This is the function. When I want to do that one, all I need to do is look for the function you want to hold or the function you want to maintain, any of them. First, I'll say that dy dx will be equal to, then you hold x squared, you maintain s squared, you multiply by the derivative of the next function. So derivative of the next function, sine 3x, you add it to sine 3x, you take sine 3x, you multiply by the derivative of the first one. So sine 3x multiplied by derivative of s squared dx. So that is it. Then your next step becomes dy dx being equal to x squared. What is the derivative of sine x? When you differentiate sine x, you differentiate 3x, you get 3. You differentiate the whole sine x, you get cos 3x plus, you hold, this is already there, so you have sine 3x multiplying the derivative of x squared will give you 2x. Now you can rewrite this. Let's say dy dx will be equal to, this time the 3x squared cos 3x plus 2x sine 3x. So we can now factorize the common variable x out. So dy dx will give us x outside, 3x cos 3x plus 2 sine 3x. And this will be our final answer. So I didn't introduce the variables, I just used the formula. This, the product rule formula is straightforward. So the same function will produce the same result, and that is what we have here. So you choose the method you want. If you want to use the variables u and v, you can use it. If you want to do it straightforward like this one, you can also use that one. So this is a division. We have a function, let's say f of x dividing another function g of x, or a function u dividing another function with v. So we apply what we call the quotient rule. We apply quotient rule for this one. So first you say that let u, I use the variables u and v, be equal to x squared, and let v be equal to 1 plus x. When you do this, you can differentiate the function u with respect to x, and then v with respect to what? X. So you say that du dx will give us 2x, and then you differentiate this one, dv dx will give us, derivative of a constant is 0 and derivative of x is 1, so we have 1. So from quotient rule, we are having dy dx giving us the variable v du dx minus u dv dx all over v squared. So this is the formula. Remember that you write v first and you take the derivative of u minus u derivative of v. If you bring this one here and you take this to this, that you are wrong, because subtraction is not commutative. 2 minus 3 is not the same as 3 minus 2. So we should note that. So you write v first, you take the derivative of u minus u derivative of v all over v squared. You don't divide here by u squared. And remember, what is v? The v is the denominator. So it is the denominator v all squared. Remember, the denominator v all squared, because v is the denominator. So I can substitute everything into the formula by getting dy dx. What is v? V was 1 plus x. So 1 plus x multiplying du dx is what? 2x minus, what is u? X squared multiplying, what is dv dx? 1 all over v squared. And what is v? V is 1 plus x all squared. So this is the function that we have. We can now expand this side. So we have dy dx being equal to, this time this will give us 2x, this time this will give us plus 2x squared, minus this time this will give us x squared all over 1 plus x all squared. So from here we can see this and this is common. So we subtract 1, we subtract x squared from this, and we have dy dx being equal to 2x plus x squared, because when this subtract you get 1 of this, all over 1 plus x all squared. This can give us, I can leave the final answer here or factorize x out. So I'll get x outside, 2 plus x all over 1 plus x all squared. So let me leave it here. You can rewrite this term by saying x out, 2 plus x out of 1 plus x, 1 plus x, or you can expand it. So I'll just leave it here. And this is quotient rule. So if I don't want to use the variable v and u as I did here, I can use the straightforward method by applying this same formula by saying that this is the function y equal to x squared over 1 plus x. So the dy derivative of this, which is dy dx, will be, you take the denominator 1 plus x, you hold it, you differentiate the numerator. So differential of x squared dx minus, you take the numerator x squared, you multiply by the derivative of the denominator 1 plus x dx, and you divide the whole result by 1 plus x, which is the denominator, all squared. So that is it. I've applied the same principle here without quoting the formula. So we just move forward. Dy dx will give us 1 plus x. When you differentiate this, you get what? 2x minus x squared multiplying. When you differentiate 1, you get 0. When you differentiate this, you get 1. So the whole result divided by 1 plus what? X all squared. So in your next step, dy dx will be equal to, this time this will give you 2x plus 2x squared minus x squared over 1 plus x all squared. So this and this is common, we already know. Will give us 2x plus x squared all over 1 plus x all squared, giving us the same x out, 2 plus x all over 1 plus x all squared. And this is it. You can subscribe to this channel if you have not, for more updates on the topics like this. This is Tutor Think, and see you in my next video.